process. There are two processes which control the generation of methane. One is biogenic and the other is thermogenic. The biogenic, and there is a slide you are seeing that the organic debris and etc. And with the heat, pressure, and temperature, the methane is generated and it is trapped in the. Next, please. Next, please. Am I audible?
Yes, sir.
Yes, sir. You are audible.
Next, please.
Abuk sir को बोलिए ना next.
Yes, sir, let me check. Babu ji is coordinating with the slides, so I'm asking he is in another room. Okay.
I'm extremely sorry. Okay. So going by the genesis, the earliest stage is called biogenic state, and here the gas is generated in the barrier history of low rank coal, where the RO value is reflectance is less than 0.5. The main important source is the thermogenic state. And in the next slide, you'll see that majority of resources is in the thermogenic state, where the RO is more, that is about more than 0.8%. And it is estimated that 100 to 300 meter cube of methane per gram of gas, per gram of coal is generated during the entire qualification process. Next, please. Next, please. What are the factors which are influencing storage capacity of methane? The first is internal surface area of coal. Coal is a very large microporous surface area. And you can imagine that it's as large as 150 to 350 meter cube per gram. Hydrocarbon gases are absorbed in monomolecular layer on the micropore surfaces. Rank is very important. Higher is the rank, better is the capacity to hold methane. Material composition is important. Indian coal is more inertinite rich, where the sorption capacity is less as compared to vitrinite rich coal, which has higher methane absorption capacity. Our mine, our coal are less gassy. Very few coal seams and very few area the coal seams are gassy, as our coal is inertinite rich. But in many countries, at many places, the coal seams are vitrinite rich and they are quite gassy, as could be seen in the Chinese coal or American coal or Australian coal. Next, please.
स्लाइड चेंज करने में सर थोड़ा सा लैग हो रहा है बट
Please. हम अतुल जी हम ऐसे भी बोल सकते हैं, मतलब साइट्स भी देखने में आसानी होती है, नहीं तो ऐसे
नहीं
बोलने में कोई दिक्कत
नहीं सर,
अच्छा ठीक
नेट की गति आ रही, शायद स्लाइड चेंज करने में थोड़ा सा लैग हो जा रहा है, तब सॉल्व
कोई बात नहीं. So in this slide, before the previous slide, there was the other slide. We show that when we do the parametric evaluation, when as a geologist, we do the parametric evaluation, what is the quantum, what will the economics, that is very important. So the geological parameters which are important for parametric evaluation of CBN project is it has the coal seams must have greater thickness. The depth of burial should be there, higher degree of tectonic activity, and the chemical and petrographic parameters are also important. It must be low moisture and low ash coal, high carbon percentage, vitrinite rich, and the rank should be volatile bituminous P to low volatile bituminous. When we do the parametric evaluation, we measure the gas content. There is a specific process to measure the gas content. We measure the gas content to know the actual quantum of gas present in that. इसके बाद next please. Hydrogeology is very important. Permeability is very important. So now, when we do all these parametric test, parametric evaluation, then now we are in a position to say whether money for commercial hardening of CBN. We do a lot of parametric studies, which includes geological studies, which include several tests, which include geophysical studies, and then we are in a position to say that yes, this area could be earmarked, could be a possible area for extraction of methane. I will repeat, I'm sorry because of the slide issues. There is slightly break in the presentations or my deliberations, but I can say that these are very capital intensive projects. They are not capital and high technology projects. They could not be taken unless a complete parametric evaluation is met, and we are sure that we are going to get a good quantum of gas extracted from the marked areas. And for such assessment, there are several software, Comet series of software, which could give you a lot of inputs for taking commercial decisions. Once the area is recognized and earmarked that this could be the possible source of cerium extraction, then the entire act is taken into a exploration phase. The moment we listen about exploration, we are very happy as a geologist. We are very conversant. We are very happy with this word exploration. So several slim holes, that is, not four holes, are drilled to know the lay of disposition, to know the physical, petrophysical studies, microclinic studies. Several tests are carried out in the slim hole drilling. We also measure the gas in place resource. What is the gas? The samples of the coal seams which are extracted, they are put in a canister, and the gas quantum is measured here. So we know what is the quantum of gas. Next, please. After, after drilling the slim holes, we go in for the pilot phase. And when the pilot phase, we do the real term CBM wells drilled, and we test at the pilot level, pilot scale. And in the pilot scale, which decide the producibility and recoverability of the reserves by simulating data generated during lesson phase and software. Fairways, which area would be a better source of resource CBM extraction is also located. In this stage, we also carry out the market survey. What is the market? अभी हम लोग ऊर्जा गंगा project चल रहा है, so that is very good. And then a development plan is prepared, which envisages the entire thing: economics, producibility, or the social impact, environmental impact assessment, etc. Everything is done. Then there is development phase. The defense is planned, and then the commercial production starts. Commercial production will take 20-25 years. So before we enter in the phase of extraction, there are 10 to 12 years, which are basic study period to minimize the unnecessary risk in the project implementation. Say, if you spend a lot of money and you don't get the return of it, then it will fluctuous decision, fluctuous investment. I will repeat that the technology is high technology. It's not very easy, but it's well proven, and we are also doing a lot of CBM related commercial extraction. CMPDI has done several things, several pilot scale, one pilot scale project, and we know the technology, and the country is now fully conversant with CBM technology. There is two high technology fields related to CBM development. Then one is perforation and the other is hydrofracturing. Perforation is when we identify that this is the coal seam, then entire well, CBM well is cased by through iron casing, and the perforation is made by putting some charges, and then the whole area is sealed. Water is pumped at a very, very high pressure just to open the cleats so that when dewatering starts, then the gas started coming out. So the whole idea is the gas is remained at a given hydrostatic pressure. When we dewater it, we are reducing the pressure and we are forcing gas to come out from the coal seams, and that gas is collected and harnessed. So that is the production technology, and that is the production technique. Next, please. This is one of the CBM drills, which was developed by CPDI, the Monitoring Project, where we had implemented a United Nations Development Plan and Government of India project called Monitoring CBM Project. Next, please. Next, please. I will explain all of it. This is what I was telling, that we case the entire hole, entire CBM well, and then we through charges we create holes in the case and then put lot of pressure. In the next slide, you will see that the hydrofracturing unit is working, and then this. So to lower the stator pressure, we do lot of dewatering, and dewatering facilitate the CBM. Yes. There is an interesting. Should I continue? मैं शुरू करूं? तुझे लगता है मैं कर पा रहा हूं? तुझे हेलो
सर
हाँ मैं कर पा रहा हूं। मैं शुरू करूं? मैं शुरू करूं तुझे? हेलो हाँ हाँ विजिबल हाँ
But slide is visible and audio is also clear. There is some technical problem.
ओके डजंट मैटर। अभी कुछ देर वो मैं करता हूं। So in this slide, friends, you will find there are two slides. Right hand slide, right hand graph shows very interesting thing that when you start See, when you start CBM, when you go intend to start CBM, you have to do a lot of dewatering. The red line, the blue line shows that initially you will be getting only water. Okay, only water, very less gas. But as the strata is depressurized, you will start getting gas, and there is a stable production gas, and then a stable production stage, and then again it will start decline. So initially you get lot of water and less gas, more less water and more gas. This is normal technology of CM extraction. Next, please. This is one of the techniques. I'm not going to going into detail of that. There are several really technologies. This is when one source, three or four coal seams, uh, coal seams spread. Next, please. International scenario when we talk about CBN development, it's, as I told you, it's a new technology. It started in the United States in early 80s, you can say late 80s. The technology was developed. And with passage, it is now a very important resource of US, contributing to about 8% of the natural gas requirement. And when I say 8%, it is huge as far as the US is concerned. The global CBM production totals around 16 MMSCMD is nothing but million standard cubic meter per day. And it is USA who is leader, and USA आता है, and Australia, China, and also India now. We are there. Yeah. We are producing about 2.5 million standard cubic meter per day at present, which going by the conversion as far as the electricity generation is concerned, so 1 MMSCMD Mota Moti produces about 220 megawatt. So India, as on date, is producing about 500 megawatt electricity equivalent from a resource which would have been otherwise wasted.
अब बैठिए
Next, please. How India got into it? We started CBM related studies in early 90s, and I'm very happy to share with you that it was started in CMPDI and under the leadership of alumni of Patna University. CM policy was put in place, announced in 1997. And consequent to CBM policy, the guidelines were there how to extract and harness CBM. And the data dossiers of the blocks, prospective blocks, were met by CMDI. We clear data dossiers on CBM prospective blocks. 33 such CBM blocks were allotted through global international bidding. Global bidding. These dossiers were appreciated. Next, please. Give you some idea what is the status of CBM development in India? I like to share that Director General of Hydrocarbon is the administrative organization to monitor the development of CBM, and they are repository of it. And they are repository of the entire data. So it's 2.6 trillion cubic meter. The prognosticated resource of CBM is 1.7 trillion cubic meter. And we have able to establish 280 billion cubic meter of resource. About 10,000 crores has already been invested, and as I told you, the current production is 2.5, which may support the 500 megawatt of power generation. But several blocks after the initial studies were not found productive for such huge investment. So there is a process of relinquishment of blocks. So the process has been started by the private. Next, please. This is just a development chart of what I have already explained. Next, please. Up till now, I have deliberated about coal bed method because of the break in the presentation due to technical errors. Just to sum up in 2-3 lines, coal bed methane is the methane which are harnessed from the areas where mining is not going on or not planned. So once the area is identified, several tests are carried out and geological parameters, producibility, etc. are examined, and then part scale tests are carried out. And after all these things, then the commercial production starts. Country as yet is not very far behind from the developed countries. It is almost hand in hand because we have already started the production of CBM, which now stands at 2.5 million standard cubic meter per day, which if not very great, but still is still good because this resource would have otherwise wasted and blown into the air during the mining. Now the second is, which is more environment friendly, is coal methane. This is extraction of that from the areas where mining is either going on or projectized. In CBM, mining is not going on or not projectized. In coal mine methane, the mining is going on. So this is the immediate advantage and to the environment. US EPA, United States Environment Protection Agency, we work very close, CMPDI and Coal India, MOC, we work very closely with US EPA, and they have estimated that 1 billion cubic meter of methane is annually released from the coal mining. We are producing about 0.8 billion ton of coal, and we are planning to increase it to meet our ever-increasing demand of electricity. So this will further increase the output of steam. Next, please. Once you harness CML ahead of coal mining, what is the advantage? There are several advantages. It ensures future mining safe for gassy mines. When I say gassy mines, there is strict classification there is a very clear classification of which mine can be said gassy. And so they are designated in 3 categories: degree 1, degree 2, and degree 3. When I say degree 1, then it is less than 1 cubic meter of gas per ton of coal mine. When I say degree 2, it is 1 to less than 10 cubic meter of gas per ton of coal mine. And when I say degree 3, it is more than 10 cubic meter of gas of coal mine. So mine safety. If you degasify it, you will minimize the risk of contamination of methane in the marine atmosphere. And as I told you, that if the concentration is from 4 to 14%, then the mixture is explosive and very little of spark or anything can explode the mine. The added advantage is we get energy, which would have been existing. Human development is encouraged in all coal producing countries. US, Ukraine, unfortunate Ukraine, they all have provided definite law for harnessing of CMM. Fiscal incentives are given, and uh, and uh, uh, and it is very much encouraged by the government. Next, please. There is a small comparison. India and China, we started together as far as CMM is concerned. But you see, China is now implementing more than 40 projects, but we have only one project which has started. So there are several issues, administrative issues, legal issues. So we take a lot of time in solving such issues. It should have been expedited. But hopefully, since several clearances are now there, so hopefully we are expecting that things will reach. Please, next. What is the role of CMPDI in development of CM? We have tried to implement few projects for harnessing, not commercialization of CMM, just to degasify, just to make the mine safe. And the one mine was Ahmedabad. The next is we implemented a CMM demonstration project under the UNDP Global Environment Facility and Ministry of Coal project in UNDP, which proved the efficacy of the CMM development in Indian geomining conditions. This was a great, great achievement, I must tell you. We are also pursuing commercial development of CBM in, I'm talking about Coal India, in two CBM blocks located in Jharia and Raniganj, and our partner is Coal. Next, please. The right hand is the hydrofracturing unit, which was deployed in the development of CMM in the Monidi project, and this is the drill machine which was owned by CMPD. Next, please. This is sucker rod pump and Monidi, which used to dewater, and this is a generator which was generating at 0.5 megawatt of power from the methane harnessed from the coal seams. And in fact, it was supplying electricity to the Monidi colony and others. As I told you, CBM and CMM production is challenging because of administrative challenges, technical challenges, safety and environment challenges. So whenever you go in for some project, challenges will always there. But what is to be done is to meet the challenges, because we, from geology background, we want to ensure that every rota of resource is identified and gainfully utilized. That is our. We don't want to waste resources. So we are giving a lot of importance to developing these resources just to meet that motto of not wasting the resource. Next, please. Next, please. Already. Explained. So, ventilation, air methane. As I told you in my initial slides, there was coal bed methane, coal mine methane, then ventilation. I told you that we do not want to waste the resource. So what is ventilation air? When the coal mining operation, particularly when the underground coal mining operation is going on, we infuse lot of air the mine in the inside the mine, and just to give fresh air for the persons working there. And while in the return, we get the air which is mixed and contaminated with methane. Typically less than 1%. The methane concentration in the return air, which in the return air of the ventilation shaft is less than 1%. But its contribution to the total coal mine methane emission is very much. It's more than 50%. So people started thinking, why not utilize it? And if you think that there is a problem, the science will provide you the answer. Technology will provide the answer. And we got the technology. In fact, America got the technology was developed in the US, where even this small quantity of methane, which is less than 1% in the mine air, will be harnessed and utilized. Next, please. We started thinking about why not to utilize this, and and we identified certain mines which are degree 3 mines of ECL, CCL, and CCL. I already explained to degree 3 here, which is the very gassy mines, and they produce more than 10 cubic meter per ton coal, per ton of coal mine. We found few mines to be potential for implementation of that technology. And a project under National Clean Energy Fund was formulated. This ISRO Australia and community mine has been contemplated. This is a project. This is still in a project stage. But if successful, it will bring the WAM technology in India. Next, please. Just on behalf of CMPDI, because I worked in CMPDI for so many years, we developed in CBM a very, very good CTM lab. Many of the features in the lab which were required was were not available readily, and we created a facility. So almost all the parametric tests for CBM and shell gas would be taken up in the lab. Next, please. These are few equipments in our lab. Next, please. Yet another interesting topic is underground coal gasification. It's a physico-chemical process of conversion of coal into gaseous energy source at the place of its operations. We don't do physical mining. But we get energy from the coal seams which are lying very deep and where physical mining is not commercially. Techno-economically unviable coal resources for mining due to greater depth, isolated nature can yield energy for present-day use through UCG, underground coal gasification. The gas is of very low calorific value, which ranges from 850 to 1100 kilocal per meter cube. The process has a lot of advantages. There's no surface disturbance. माइनिंग हो नहीं रही तो सरफेस डिस्टर्बेंस क्या होगा? छोटा छोटा जगह से कोल जा रहा है, ऐश नहीं निकलता है, देयर नो ऐश और स्लैग. साइट रिहैबिलिटेशन नहीं का जरूरत पड़ता, रिहैबिलिटेशन का जरूरत नहीं पड़ता, एंड CO2 का emissions का रिडक्शन होता है. नेक्स्ट प्लीज. Internationally, this is a proven technology. We have visited few places where the technology is going on. Next, please. These are the UCG trial sites. Next, please. Next, please. So this is the process of underground coal gasification. Coals are drilled. The coal seams are ignited underground. And the gases which are produced are harnessed by the second bore. There are two boreholes. And once the gases are harnessed, they are put for commercial utilization after doing the necessary enhancement or necessary cleaning of it. Next, please. This is the advanced method of doing the UCG, where directional drilling in coal seams and controlled injection of oxidants are. It's called CRIP method, controlled retracting injection point. This is also utilized. Next, please. As in case of CBM, CMM, VAN, etc., India is not very far behind in taking up UCG even at the concept level. Why UCG in India? Because our coal are low ranking. Some of the coal are isolated where mining is just not possible with the present economics. These coal mines, these coal seams, isolated nature, lying at great depth, they are the ideal source of taking up UCG. Just imagine in 1980s, we thought of carrying out UCG under the collaborative regime with USSR. A lot of data were generated in Mirta Road lignite deposit of Rajasthan. CPDI was generating data. The place was found suitable for taking up UCG. But there were great concern, correct or incorrect, I will not make any comment. There is great concern about the environmental factors and contamination of groundwater, particularly. So the project, after finding it viable, the government, and it could not proceed ahead. But now the technology is advanced, so now we are in a better position to take up the UCG, and that is what is presently being thought of. Next, please. This is now a priority area, at least at concept level, at least at the pilot scale level. The government has given notification in 2007 and for taking up UCG through public-private entrepreneurs. A guideline was issued in 2009 and Gazette notification 2016. The state notification will expedite commercial development of UCG in the country. I want to share with you that many of our ideas, many of our projects are delayed because of several clearances which are required. I don't say the clearances are not necessary, they are necessary. But expeditious disposal of the clearances will only help country to achieve the high technology which is very much required to the energy supply scenario. Next, please. CMPDI, like in all other non-conventional coal-based clean energy source, CMPDI has also taken a lot of steps. In fact, tenders were floated for selection of prospective bidders in the two identified blocks, but because of certain proceed further. And I can only say the further actions are being taken because because in 2011 we had advanced and we had taken steps which were looking back